Welcome students. Clausius Claperyon equation. This Clausius Claperyon equation is a relationship between saturation pressure, temperature, enthalpy and a specific volume during the phase change process. So this equation provides a basis for calculations of properties in a two-phase region. So from the Maxwell's relation, we know that dou P by dou T at constant volume is equal to dou S by dou V at constant temperature. Now consider the change of phase, that is from a liquid to vapor state, that is from saturated liquid to saturated vapor. I can write the above equation as dP by dt at here a constant volume will be coming, but since it is a phase change process from liquid to vapor, that is evaporation process. So during the evaporation process, the pressure and temperature are independent of this volume. So no need of writing this volume, and I am writing dP by dt. So this is equal to change of entropy. I am having a temperature enthalpy curve. So if here it is in liquid and here it is vapor, this region, in the wet region, for converting from the saturated liquid to saturated vapor, the amount of heat, that is the enthalpy, or I can say it as a latent heat, that is added during the evaporation process. So change of entropy is Sg minus Sf. So during the evaporation process, what is the change of entropy? Here the entropy is Sg and here the entropy is Sf. So the entropy change Sg minus Sf, and similarly during evaporation process, the change in volume is given by Vg minus Vf. So Vg is the specific volume of the saturated vapor and Vf is the specific volume of the saturated liquid. I can write like this also, Sfg divided by Vfg. dP by dt is equal to entropy is equal to the change of entropy during the evaporation process is equal to the enthalpy change during evaporation divided by the absolute temperature. That is given, instead of S I can write enthalpy change divided by temperature, and here I am having a specific volume Vfg. So this equation, that is dP by dt is equal to Hfg divided by T into Vfg. So this equation is called as the Clausius Claperyon or Claperyon equation. This equation is called as the Clausius Claperyon or Claperyon equation for the evaporation of liquids. For evaporation of liquids. this dp by dt, this term gives the slope of the curve, that is this vaporization curve. So I am considering the two phase that is from liquid to vapor. So here I am having liquid and here I am having vapor. So during the transition from liquid to vapor only I am considering here. So what is the curve that will be coming here? It is the vaporization curve. So for this, if I take the slope, so what is the slope formula? It is dy by dx. Here instead of y I am having P and instead of x I am having temperature. So I can write dP by dt. So the slope of the vaporization curve in our case is dP by dt, and that is equal to hfg divided by T into Vfg. So at low pressure, what happens is Vfg is equal to Vg. Therefore, this equation dP by dt becomes hfg divided by T into Vg. Also we know that PV is equal to RT, or I can say V is equal to RT by P. So instead of V I am substituting RT by P. So this is equal to hfg divided by T into RT by P. This becomes hfg into P divided by RT square. Here I am having dP by dt. Now I am rewriting this equation as hfg is equal to RT square divided by P into dP by dt. Just I am rewriting. Now take the pressure term on one side and remaining on the other side. So dP by P is equal to hfg by R into dt by d square, or instead of t square I can say t power minus 2. Now integrate both sides. Here hfg by R is constant, so I am integrating here. This will be giving dP by P as ln P limits from 1 to 2 is equal to hfg by R. If we integrate t power minus 2, we will be getting t power minus 2 plus 1 divided by minus 2 plus 1. So that is t power minus 1 divided by minus 1. So I am writing in a single step t power minus 1 divided by minus 1. So limits 1 to 2. So I am copying this equation for carrying out the work in the next page. So ln P2 by P1 is equal to HFG by R minus 1 by T limits 1 to 2. So if I remove the minus sign, the limits will be changing. So I am removing the sign and also changing the limits from 2 to 1. So ln P2 by P1 is equal to HFG by R into 1 by T1 minus 1 by T2. So if we know this pressure and temperature, this vapor pressure at a particular temperature, then we can calculate this vapor pressure P2 at the temperature T2. Thank you.